Hi, this is the I'm studying in Institute of Aeronautical Engineering. I'm studying BTech first year Computer Science Engineering. Today we are going to discuss about galvanic series. Galvanic series is also known as electrochemical series. Galvanic series also determines referred to an activity series as a list that describes the arrangement of elements in order to the increasing electric potential values. The galvanic series determines the electrochemical potential and nobility of metals and metal alloys. When two metals are submerged in an electrolyte while also electrically connected by a metallic conductor, the less noble metal will experience galvanic corrosion. The less noble metals becomes anode and corrodes faster and become oxidizes and it undergoes oxidation. It will all by itself, while the other becomes cathode and corrodes slower than it would be. It will also undergo corrosion but slower process. The galvanic series is also known as electrochemical series. Galvanic series, also sometimes referred to as activity series, is a list that describes the arrangement of element in order of their increasing electric potential values. Before going to the depth in galvanic series, we will just discuss about galvanic cell. Galvanic cell arises when two metals with dissimilar compositions come into contact in the presence of an electrolyte. The rate of corrosion on the less noble metal is determined by the electrolyte. The difference in the nobility and the relative areas of the anode and cathode exposed to the electrolyte. From the galvanic series, we can justify that in the galvanic cell, which metal there are two metals taken in the galvanic cell. For which metal act as anode and which metal acts as anode, we can justify from the galvanic series. And which metal undergoes corrosion, which metal undergoes reduction, we can definitely do it from galvanic series. In the diagram, we can see that we have taken zinc electrode in zinc sulfide and copper electrode in copper sulfide. We have taken two elements, zinc and copper. Electrons definitely transfer from anode to cathode, positive to negative, positive to negative. Anode axis, oxidation takes place at anode and reduction takes place at anode. Both the zinc ion concentration and copper ion concentration are maintained at balance in salt bridge due to the salt bridge. Salt bridge maintains the ionic balance. Zinc undergoes oxidation and copper undergoes reduction. This diagram lists metals and alloys potential in the order of reactivity in seawater versus zinc and silver chloride in seawater and soil versus copper sulfate. Difference electrode. We have taken three reference electrode with different values. Top listed metals are alloys, are noble metals which are less reactive than the metals which are below listed metals, are anodic metals, most active metals or alloys. When we take in reference electrode as zinc in seawater, from platinum to magnesium, electric potential value going on decreases because electric potential value decreases. From platinum 1250 to magnesium minus 385. When we have taken silver and silver chloride in seawater as reference electrode, from platinum to magnesium the value changes, but at the graph same decreases from top to bottom. In copper sulfate reference electrode in soil also 150 to minus 168. Definitely decreases from top to bottom. In the first zinc in seawater reference electrode, the zinc anode alloy is 0. Electric potential value of zinc anode alloy is 0 because we have taken different electrode in different electrodes as zinc in seawater. Zinc in seawater is also known as zinc anode alloy. Now we will see the different electrode as standard hydrogen electrode. Therefore, the electric potential value of hydrogen is 0. From fluorine to lithium, the electric potential values decreases from top to bottom. Fluorine is a good oxidizing agent. It reduces in the faster rate. In the galvanic series, standard reduction potential value decreases from top to bottom. As we can see in the series, standard reduction potential value decreases from top to bottom. From fluorine to lithium, the standard reduction potential value decreases. In the galvanic series, standard oxidation potential value increases from top to bottom. As you can see, from top to bottom, when the standard reduction potential value decreases, standard oxidation potential value are definitely opposite, so it definitely increases. The elements in galvanic series having higher standard reduction potential values undergoes reduction and having lower standard reduction potential values undergoes oxidation. As we can see, fluorine having higher standard reduction potential value, therefore it is a good oxidizing agent and undergoes reduction. Lithium having strongest reduction potential. Sorry, lithium is having low reduction potential value, therefore it definitely undergoes oxidation and its strongest reducing agent because it is having higher standard reduction potential value and more strongest oxidation potential value. The elements in galvanic series having lower standard oxidation potential values undergoes reduction, and the elements in galvanic series having higher standard oxidation potential values undergoes oxidation. The strongest oxidizing agent and weakest reducing agent in the galvanic series is fluorine. The weakest oxidizing agent and the strongest reducing agent in the galvanic series is lithium. As we as we can see in the series that fluorine is having higher standard reduction potential value, therefore it undergoes reduction, therefore it is strongest oxidizing agent. The elements which undergoes reduction are known as oxidizing agent. The fluorine undergoes reduction in the faster rate, so it is known as strongest oxidizing agent, and the fluorine can oxidize the elements present below it. Lithium is known as strongest reducing agent because it undergoes oxidation at faster rate. Lithium undergoes corrosion at faster rate. Lithium can reduce the elements present above it. Therefore, it is known as strongest reducing agent. The elements having lower standard reduction potential value can displace the element having standard reduction potential value. As you can see in the series, the elements which are below hydrogen having lower standard reduction potential value and above hydrogen having higher standard reduction potential value. The elements present below hydrogen can displace the element present above hydrogen, or the elements which are having lower standard reduction potential value can displace the elements having higher standard reduction potential value. The elements which are present below the elements which are present below the certain elements can displace the certain elements in the displacement reaction. The elements which have negative standard reduction potential are more active metals than the elements having positive standard reduction potential value. As you can see in the series, the elements having negative reduction potential value are below the hydrogen and the positive reduction value are above the hydrogen. The elements which are present above the hydrogen are called as noble metals or less reactive metals. They are available in free state, but the elements which are below the hydrogen are having a less reduction potential value. They are more active metals, so therefore they can displace the metals above the hydrogen and above themselves. As you can see in the series, lithium can displace the elements present above it, and potassium, calcium, sodium, magnesium, aluminum, magnesium, hydrogen, water can displace the elements above it. Lithium is a more active metal because it can displace all the elements present above it. From the electrochemical series, we can see that which metal undergoes galvanic corrosion. If there are two metals which can undergo oxidation and which can undergo reduction and which can undergo corrosion, we can justify as we justified it in galvanic cell. If there are more than two metals, there are three metals, four metals, then it means more than two metals. We can say that which metal undergoes rapid rate corrosion. Corrosion is a natural process that converts a refined metal into more chemically stable forms such as oxide, hydroxide, carbonate, or sulfide. It is gradual destruction of materials, usually a metal, by chemical or electrochemical series reaction with their environment. Corrosion is disintegration of metallic material from its surface by chemical or electrochemical reaction with its environment. When metal undergoes corrosion, differently energy is released. When metal undergoes corrosion, metallic compound and energy are released as products. From the galvanic series, we can justify that which metal undergoes corrosion. Okay, the elements having lesser standard reduction potential value. The elements present below hydrogen undergoes mostly oxidation. Definitely, the elements which undergoes oxidation will undergo corrosion. There are some important points to discuss. In the galvanic series, standard reduction potential value decreases from top to bottom In the galvanic series, standard oxidation potential value increases from top to bottom. The elements in galvanic series having higher standard reduction potential value undergoes reduction. The elements in galvanic series having lower standard lower standard reduction potential value undergoes oxidation. The elements in galvanic series having higher standard oxidation potential value undergoes oxidation. The elements in galvanic series having lower standard oxidation potential value undergoes reduction. In the galvanic series, standard reduction potential values and standard oxidation potential values are arranged in the list so that we can justify that which metal undergoes corrosion, which metal undergoes oxidation, which metal undergoes reduction. In the galvanic series, standard reduction potential values decreases from top to bottom. In the galvanic series, standard oxidation potential value increases from top to bottom. The elements in galvanic series having higher standard reduction potential value undergoes reduction. The elements in galvanic series having lower standard reduction potential value undergoes oxidation. The elements in galvanic series having higher standard oxidation potential value undergoes oxidation. The elements in galvanic series having lower standard oxidation potential value undergoes reduction. Strongest oxidizing agent and weakest reducing agent is in galvanic series is fluorine. The weakest oxidizing agent and the strongest reducing agent in the galvanic series is lithium. In this series, standard reduction potential value of oxidizing agent decreases from top to bottom. In this series, standard reduction potential of reducing agent decreases from top to bottom. The elements which oxidize other metals are oxidizing agent. Simply we can say that the elements which undergoes reduction are known as oxidizing agent, and the elements which undergoes oxidation are known as reducing agent. Mostly the corroded metals are reducing agent, good reducing agents. The elements having lower standard reduction potential value can displace the elements having higher standard reduction potential value. The elements which have negative standard reduction potential value are more active metals than the metals having positive standard reduction potential value. The strongest oxidizing agent and the weakest reducing agent in the galvanic series is fluorine. The weakest oxidizing agent and the strongest reducing agent in the galvanic series is lithium. In the series, standard reduction potential value of oxidizing agent decreases from top to bottom. In the series, standard reduction potential value of reducing agent decreases from top to bottom. The elements which undergo oxidation are known as reducing agents. The elements which undergo reduction are known as oxidizing agents. The elements which reduces the elements are known as reducing agents, and the elements which oxidizes the elements are known as oxidizing agents. The elements having lower SRP value, standard reduction potential value, can displace the elements having higher standard reduction potential value. The elements present, okay, lithium is present below, but at the bottom of the series. Therefore, it can reduce all the elements present above it. Therefore, it can displace all the elements. The elements which are negative standard reduction value, more active metals, and which are positive standard reduction value, less active metals. The noble metals are less active metals are available in free state. Let us discuss about the corrosion. In the corrosion, galvanic series, we can justify that which metal undergoes oxidation, which metal undergoes reduction if there are two metals, and which metal acts as cathode and which metal acts as anode, as we just previously justified in the galvanic cell. In the corrosion is a natural process that converts a refined metal into a more chemically stable from such as oxide, hydroxide, carbonate, or sulfide. It is a gradual destruction of materials by chemically or electrochemical reaction with the environment. Corrosion is a disintegration of metallic material from its surface by chemical or electrochemical reaction with its environment. When metal undergoes corrosion, then definitely there will be some energy released. When metal undergoes corrosion, metallic compound and its energy are released. Uh, Corrosion is a natural process that converts a refined metal into a more chemically stable from such as oxide, hydroxide, carbonate, or sulfur. It is gradual destruction of materials by chemical or electrochemical reaction with their environment. Corrosion is disintegration of metallic material from its surface by chemical or electrochemical reaction with its environment. When metal undergoes corrosion, definitely metallic compound and plus energy, definitely energy is released. From the galvanic series, we can justify that which metal undergoes galvanic corrosion, as we previously justified as galvanic cell. Which metal undergoes anode, which metal acts as anode. The metal acts as anode undergoes corrosion, undergoes oxidation. If there are more than 2 to 3 metals, We can verify that which metal undergoes rapid rate of corrosion. From the galvanic series, we can justify that which metal undergoes corrosion. The elements having lesser standard detection potential value acts as anode and undergoes oxidation. Act as definitely acts as anode and undergoes oxidation. The elements which undergo oxidation will definitely undergo corrosion. Corrosion from corrosion, we can get rid of corrosion by corrosion control methods. We can paint, we can use galvanizing process, we can use osmosis, reverse osmosis process, and we can use ion exchange process to get rid of corrosion. The corrosion definitely two types: oxidative corrosion, detective corrosion. From Pilling Bedworth rule, we can justify that which metal from specific volume ratio, which metal undergoes corrosion. Thank you.